Hello and welcome back to Teachita. Today we're gonna learn something new, Bernoulli Differential Equations. These equations are in the general form of y prime plus y fx equal to y to the power of alpha rx. To solve them, this is the general form. To solve them, we will divide the equation by y to the power of alpha, and then from here we would get y to the power of minus alpha plus y over y to the power of alpha fx equal to rx, which is y prime y to the power of minus alpha plus y to the power of minus alpha plus 1 fx equal to rx. Now we're gonna change a variable u equal to this term, y to the power of minus alpha plus 1, and from here we're gonna write down u prime is equal to minus alpha plus 1 y prime y to the power of minus alpha plus 1 minus 1, which is equal minus alpha plus 1 y prime y to the power of minus alpha. So you can see y prime y to the power of minus alpha is u prime over 1 minus alpha. So we can plug them back in the equation up there. U prime 1 minus alpha plus u fx is equal to rx, which is a linear differential equation, and we've seen how to solve them. So let's take a look at some examples. Y prime, example 1, y prime plus y is equal to x y squared. So from here we know alpha is equal to 2, and then if you can remember, we're gonna divide by y to the power of alpha, which is basically y to the power of 2. So from here we get y prime y to the power of minus 2 plus y to the power of minus 1 equal x. Basically, I'm gonna show you the steps right here. So from here, y prime over y squared plus y over y squared equal x. And then next step would be the change of parameter u equal y to the power of minus 1. Therefore u prime is gonna be minus y prime y to the power of minus 2. So you can see now this equation right here is changing to u prime minus u is equal to minus x. And then we saw how we solved this before, right? So hx is equal to minus x. Therefore 1 over y is equal to u equal e to the power of x integral of minus x e to the power of minus x dx plus c. And that would be the solution. Let's take a look at another example. Y prime plus y equal to y squared cosine x minus sine x. Again, we're gonna divide by y to the power of 2, so we would get y prime y minus 2 plus y minus 1 equal to cosine x minus sine x. And we're gonna use u equal to y to the power of minus 1. Therefore u prime is equal to minus y prime y minus 2. From here we will get u prime minus u is equal to sine x minus cosine x, and therefore we know hx is equal to minus x, and 1 over y again equal to e to the power of x integral of sine x minus cosine x e to the power of minus x dx plus c. And that's how we will solve this. Let's take a look at another example. This time y prime is equal to x squared plus 2y squared over xy. So let's open this up. Y prime minus 2 over x y. So basically I'm going to bring this term to the other side, equal to x over y. As you can see, alpha is equal to minus 1 now, right? 1 over y equal y to the power of minus 1. So from here I'm gonna be dividing by y to the power of minus 1, which is gonna give me y prime y. Let me show you. Y prime over 1 over y, right? Minus 2 over x, y over 1 over y equal to x over y over 1 over y. So from here you will get y prime y minus 2 over x, y squared equal to x. Again, u would be y squared, and from here u prime would be 2y, y prime. Therefore I'm gonna get this equation changes to u prime minus 4 over x u equal to 2x. hx would be minus 4 ln x. You need to refer to previous lectures to see how we get there, but again u would be equal to y squared x to the power 4 integral of 2x x over 4 dx plus c. And that's how we would be solving this equation. Let's take a look at one last example. Example number 4. dy over dx is equal to x squared y plus y3. So let's turn this around. Basically we divide 1 over. So it would be dx over dy equal y3 over x plus xy, or I can open this up further, just multiply by x. We're gonna get x dx over dy minus x squared equal y cubed. So now this is Bernoulli with respect to x, correct? And then alpha in this case is minus 1, right? So now I can say u is x squared, therefore du over dy is equal to 2x dx over dy, correct? And then from here I can write down du over dy minus 2y u is equal to 2y to the power of 3, and here now linear with respect to y, so h of y would be minus y squared, and from here u equal to x squared equal to e to the power of y squared integral of 2y3 e to the power of minus y2 dy plus c, right? So you would integrate by part, part and change of variable t over y2, and then you will solve this. That's all for Bernoulli's equations. In the next lecture, we're going to look into orthogonal trajectories, and that would be it for this course. Thank you very much. See you guys next time.